There are more viruses in the universe than there are stars. We know of approximately 1.6 million viruses, yet we have only identified about 5 thousandths of them. The vast majority remains a complete mystery.
Greenland and the permafrost is really very important. That has been for a long time. In the permafrost is factor X, we don't know. Professor Claverie published a number of new viruses that he hadn't seen before, that haven't been described before.
Greenland, a name recently dominated by geopolitical debates, is it actually a ticking biological time bomb? Could there be a secret buried beneath this massive white sheet, far deeper and more unsettling than any political dispute? Could microorganisms, waiting for tens of thousands of years to wake from their slumber, return to our world as the ice melts? Permafrost, the ground that has remained frozen for millennia, acts as a natural time capsule, preserving ancient microorganisms unknown to humanity. But what happens if the doors to this frozen prison are flung open? Could these sleeping giants spark a new global pandemic? I turned to two expert scientists with this burning question. Their answers were thought-provoking. Before we wake these ancient entities, we must understand what is happening inside nature's deep freezer.
A pandemic requires specific conditions. You need a virus that humanity has never encountered before. A virus in the permafrost would be exactly that. Humans have existed for about 200,000 to 300,000 years, but viruses are much older. There are likely many viruses out there that we have never touched or identified. So, that first condition is met. However, the R0, R sub-zero value, the rate at which one infected person passes the virus to others, is critical. Does one patient infect one person or 15? For diseases like measles or the flu, this rate is very high, which is why they spread so rapidly into outbreaks. In short, it takes 6 or 7 specific conditions for a microorganism to cause a pandemic. We don't yet know how many of these conditions are met by the viruses under the permafrost. That is why this is a subject that demands our closest attention.
The permafrost thawing, that means that it's going to be somewhat easier to get access to all the resources there, but it also means that we're going to dig into millions of years of permafrost, and where we have lots of microbes resting. Professor Jean-Michel Claverie has published, and together with his team, and also researchers in Novosibirsk in eastern Siberia, that you can recover microbes that have been dormant for at least 50,000 years. French group, they could actually reactivate the virus and infect amoeba cells with it. And of course, some of these microbes are unknown to Homo sapiens, our species. And our immune defense has developed without being close to these microbes. So they are unknown to us. It has to be more in focus of research before we start to dig into the thawing permafrost.
Professor Evengård emphasizes that because carbon dating can only measure back about 50,000 years, the 50,000-year figure is merely a minimum. The viruses could, in fact, be much older.
Even if they are isolated cases, studies show that significant human viruses, like the supposedly eradicated pox virus, could be buried there. Influenza or herpes viruses might also be found. These will eventually be documented, but whether they will rise up and cause a pandemic, that remains somewhat speculative. The real risk lies in antibiotic resistance genes that are currently unknown to us. In bacteria found there, which we assume won't cause a pandemic, there are unique resistance genes we aren't used to. As the permafrost melts, these genes will mix into the environment and transfer to those in contact with it. We could face microorganisms resistant to every treatment in our current medical arsenal.
Could you elaborate on that?
Antibiyotik direnç genleri bulunuyor bu bakterilerde, o bölgede bulunan bakterilerde. Çünkü
The bacteria in that region possess evolutionary resistance genes.
basit bir konu değil antibiyotik direnci.
This isn't just about the misuse of antibiotics today, it's an ancient evolutionary trait.
Permafrost tabakasında bulunan bakterilerde
Research confirms these genes exist in the permafrost.
bu önemli bir nokta. Çünkü bu antibiyotik direnç genleri oradan yayılır ise
This is a pivotal point. If these resistance genes spread and are suddenly transferred to the bacteria we already know, we could lose the ability to treat diseases that are currently easy to cure.
geleceğimiz bir takım hastalıkları tedavi edemiyor olabileceğiz.
How would they be transferred?
They can be transferred through various pathways during contact between bacteria. It doesn't necessarily have to start with a human infection. This transfer can happen in nature, which is a dangerous prospect.
Ve buzun altındaki permafrosttaki virüsler.
Can viruses remain viable under the ice for millions of years without ever waking up?
For viruses to survive this way, they need two things: a cold environment and an anaerobic or oxygen-free environment. The permafrost layer provides both. It is extremely cold and a sealed oxygen-free space. Viruses can persist there. As for most bacteria, they generally cannot survive indefinitely, with one exception: anthrax. Anthrax can encase itself in a shield, spores, and protect itself for incredibly long periods.
Zırh içine alır ve bu şekilde bir zırh içinde yaşamını çok uzun süre koruyabilir.
Bu risklerin
One of the most striking examples of these risks occurred in Siberia in 2016. Anthrax bacteria, released from a reindeer carcass exposed by melting permafrost, infected living herds. Over 2,000 animals died, dozens of people were infected, and a 12-year-old boy lost his life.
It is a bacteria.
It's a bacteria with a very strong cell wall, so it can be dormant for at least 100 years, probably longer.
And it was awakened or released by the climate change?
Most probably, it has, yes, because it was released because animals have died from anthrax, and then they have been buried in the permafrost. And of course, it's difficult to dig in the permafrost, so they were just close to the surface. So when the permafrost starts to thaw, these bacteria entered the earth.
Arctic Ocean currents carry these waters across the globe with staggering speed, completing the journey in just a matter of weeks.
Most people probably think that the Arctic is somewhere way in the periphery. Big currents in the ocean, they travel around the globe just within weeks, transporting all kinds of things and things being released from the permafrost. And you must remember that 22% of the surface of the globe is permafrost. 22%. And the largest area is, of course, Siberia, where we have very little access these days to what's going on. And this is a disaster that we talk way too little about, you know. Here we have three huge rivers, Ob, Yenisei, Lena, and they transport all kinds of debris out into the ocean. And then this is transported within a couple of weeks through the Atlantic to the Indian Ocean, Pacific, etc., and then back.
What happens in Arctic doesn't stay in Arctic. Is that correct? Like it travels?
Yeah. Yes, that's absolutely correct.
Because what happens in the Arctic doesn't stay in the Arctic.
Sulara karışaraktan elbette bakterilerin birbirleriyle teması söz konusu olacaktır. Yani söylemeye çalışıyorum.
Bacteria mixing into the water will come into contact with one another. This exchange happens quite easily in nature, not just through human infection. These environmental exchanges are the real danger. The human population in the Arctic is small, about 3.5 million, but it is increasing due to mining, migration, and drilling, which facilitates human contact. Beyond that, climate change is shifting bird migration routes. As temperatures rise, insect habitats change. These act as vectors, carrying those viruses to human populations. All these risks are on the table.
örneklerin hepsi var tabii. Yani bunlar biliniyor ve izleniyor, izlenmesi lazım.
I think that's
Such
a very good
practices.
expression. Yeah, that's a good expression you have, irresponsible, because you have to see the larger picture that you could actually start a pandemic. It's not, we don't know, it's factor X, and we shouldn't be, making a drama. But what I'm pointing out and what Professor Claverie pointed out, we need to find out more. Well, I don't think we can expect industry to be careful. It has to be regulations around this. And I'm talking about international regulations that's really strong and clear. At least it should be discussed. International regulations about industry moving into the Arctic. It's not just going there for the resources. You have to take precautions, because otherwise we'll have, most probably, although no one knows for sure, we'll have more pandemics. We know too little about it. We need to look for these microbes and other whatever can be down there, because we're talking about millions of years of permafrost. Things are stored in there.
Permafrost'un çözülmesiyle beraber
As the ice melts, the Arctic becomes more attractive to industry. But permafrost is not just frozen soil. As it thaws, it releases more than just water. It unveils a biological archive that humanity has never seen before.